All right. Hello, everybody. I think we got everything squared away, so we're going to go ahead and start this. I want to thank you for being here today, taking your time. Good morning to the people on the West Coast and good afternoon to everyone else. We're excited to be here with you today. And this is our first webinar that we're doing as a team here at Scinomix, Lab Automation Made Simple. And this is going to be understanding automated sample aliquoting, in particular, our sample aliquoting machine, the Scinomix AQ. All right, we'll go ahead and get started. All right, so who am I? I'm Lucas. I'm an account manager here at Scinomix. Previously to taking the role here at Scinomix, I was in college. My degree in formal education is in molecular cell biology. So I did kind of a lot of lab work and am familiar with some of the pain points that labs experience. Just doing that, for those 4 years of time that I had in university. I took this job as starting in QC, and then recently I started on as a role as account manager. So I'm really here to help you all, with precision workflows, and here to answer questions, things like that. I'm also here with my co-panelist, Nick Shepard. He is our sales and service manager. He's kind of helping with things on the back end, and he's excited to be here himself. All right. So kind of a brief overview of what we're going to be looking at today. So we're going to do a deep dive into the Scinomix AQ system. We'll show you a live product demonstration of the AQ, and then we're going to open it up to a Q&A section kind of at the end. Before we get to the Q&A section, we will do just some frequently asked questions, so hopefully we can kind of answer a lot of questions there. But if you have any questions, please use the Q&A section in your toolbar for your Zoom. We have disabled the chat, so make sure that that's winding up in the correct spot. All right. Okay. So the slide's a little bit elaborate. We'll just kind of take it in tow and go through each one of these points here. So the purpose of this slide is that high price of manual labor. So how can automation help, and how is maybe manual old ways kind of hurting? So there's financial impacts to sticking around with your manual pipetting ways, one of which is the rise of labor costs. So each year, employee and human labor is going to rise, right? Versus this automation approach, that's that one-time upfront cost. And these systems work for years. Once you have it, it's going to be a robust system. As we know, errors can be expensive, right? So we have to fix those errors. We have to use new material. We have to get people together to understand these errors, things like that. That can all be very expensive to handle. So that automation is helping by just doing that same process over and over. Kind of maybe eliminating some of that human error. And then training. So if you're constantly having to train new lab users for your workflows and have them understand what's required out of them, that can be very costly, both from time and money, right? So these systems store all of your workflows, and it's as simple as training a user how to select the correct workflow and just simply press go. That's where automation is really going to be beneficial from that financial standpoint. What's kind of the drawbacks to sticking to these manual ways? So one of which is losing that competitive edge, right? So if you have downstream R&D processes that you're doing these aliquots for, things like that, that department might be held up, where otherwise automation can be running in the background, churning out large amounts of samples without user intervention, keeping everything moving streamlined within your company. Client relations, of course, is most typical. So problem here is you're going to start reaching into those bottlenecks, which we'll talk about here in a minute, where that manual hand pipetting is taking a lot of time. Clients require things quickly. They require things to be accurate and done correctly the first time. Again, that's where that automation is going to benefit you, giving you the same thing at the same time every time. And then most basically, poor ergonomics, right? So if you're doing those 1,000, tube fills before the weekend's over, one of your lab users is surely probably going to have carpal tunnel by the end of it. At minimum, they're going to have, sore hands. So getting those manual pipettes out of the hands of individuals and just letting automation handle this is going to help morale. It's going to help your physical and overall just health. And then quality and accuracy, right? So surge in error rates, we see a lot. This can be things just like human error. Which happens. Things like no label on the barcode, under or overfilled, decimal places being in the wrong spots. These can cause drastic errors that can really increase time spent with correction of these problems. Whereas automation, you're going to get the same thing every time. That data integrity we talked about a little bit. So that's, those bad decimal points and just overall bad data that you're getting. And then compliance complications. This is a good one. So these systems that we sell here, they all have result data files. So they're going to export everything that happened to every single tube. You can upload this into your lab management system, and you'll have a record of what happened to every tube, what happened in every run, and what happened with all of your workflows. It's going to give you that robust data file where you can figure out what happened to each individual tube. Productivity and efficiency decreases with manual ways, right? So those are those bottlenecks and delays I was talking about. This is where your lab users are having to use their valuable resources like their time to be aliquoting by hand, whereas we can free up those resources of human labor to do other things like data analytics and things of that nature, where we can omit those bottlenecks. We have machines running in the background while lab users are doing something completely different that might relate to the process in total. And then resource management. That's what I was talking about. Probably the greatest resource in your lab is going to be your employees. They're the ones that know how to do these workflows, the ones that know what they're doing. So freeing up their resources to do other things that's not maybe as mundane as hand pipetting can really be a benefit to your lab. I know back when I was in my labs, pipetting was the first thing we learned, right? So that's not a complicated thing to do, but it is very time consuming. So getting those resources back into your corner, having them as assets, getting the pipette out, that's really where automation is best. And then operational mishaps is kind of what we've been covering. So those data disasters, improper data results folders, bad notebook taking, wrong decimals, overfilled or underfilled tubes, that can all be omitted using this automation. And then sample handling slip-ups as well, right? So, you could spill a tube, drop a tube, fill the wrong tube, things like that. Automation, it just doesn't happen that way. It's handled one tube at a time, and if there's going to be errors, we can kind of circumvent those errors using automated error handling processes. All right, so we're going to kind of move on here, but hopefully that helps you just understand maybe the importance of getting those pipettes out of the hands of your people and putting them into an automated workflow. All right, so right here in a minute, we're going to start doing a kind of a live product demo. So what are you going to see in this product demo? So starting from left to right here, we have our Scinomix AQ module over here on the left. This is going to be where that onboard single channel air displacement pipette lives. This is where all of your aspirations come out of your source liquids. It has a 9 work deck position, so it's got a large work deck that can handle numerous different sizes of labware. Most size tubes. It can handle basically any liquid. So that's going to be that robust aliquoting module. Now, it's important to note here that this aliquoting module, the Scinomix AQ, which you see attached here, can be retrofitted with existing VXLs, which I'm about to explain here in a minute. But you don't have to buy an AQ system standalone. If you have a Scinomix VXL, that module can just be added on to the left and retrofitted. So the Scinomix VXL that I've been talking about, this is kind of the workhorse from a destination tube side, right? This is where your tubes are getting uncapped so that they can be filled, where they're getting labeled, they're getting barcoded with those labels if you prefer that option, barcode scanned, and even weighed. So we have gravimetrics and things like that that are going to make this an all-in-one workstation. Over here on the far right side is the Scinomix VXI bulk tube feeder. This is very beneficial for if you're buying your tubes in bulk and you get them in bags, and you simply want to take the bag, load it into our hopper, and just deliver them to the gripper using that automation step. So effectively how this system comes together in total is over here starting on the right. The bulk feeder will send a tube to our labeling module here in the middle, the Scinomix VXL. The VXL will then uncap it. At this point, the aliquoter is coming in to deliver all of its liquid to that tube. Once the liquid's been delivered, the aliquoter will return over its source tube. It gets capped, labeled, and put back into a rack. So at run end, you can expect to just open the doors of the instrument and just pull off racks of filled and labeled tubes. All right, we're going to keep on rolling here. All right, so why really use the Scinomix AQ system? So Scinomix is simply easy. That's really the benefit of everything that we have set up here. We have those precision aliquoting and accurate aliquoting, so you can sleep easy at night knowing that this system's calibrated and doing the right thing, even if you're not paying attention to it, maybe. It has versatile workflows, so you're not limited to just one workflow. You can create numerous different workflows with numerous different types of labware, numerous different types of liquids. And once that workflow is created, it's as easy as just selecting out of a drop-down menu which workflow you aim to achieve and pressing go. We have very user-friendly software, and this is going to be super convenient for your lab. This is where you can build those workflows that I was talking about without having Scinomix techs on site to help you through this. This is something we teach you at installation. It's as simple as adding new labware, directing the system to know where it's going, and pressing go again. Very user-friendly, very convenient to work our software. And then it's simply easy because it can have a lot of things on it. It can have those gravimetrics. It can have the barcode scanning. It can have tube labeling and uncapping. That's going to make your life easy knowing that one benchtop machine is capable of numerous different workflows. And something that I really want to make known here is that all these systems that I'm talking about, including the AQ and the VXI and the balance with gravimetrics, those are all modular. So you don't have to start with what you finish with. You can start with just buying the VXL and add these modules in at your liking. It's going to be super beneficial to know that one purchase may not be wasted. You can add things later as things develop within your company. All right, so you've heard me talk a lot about the workflows that we do. So what are the most common ones that we see? Sample aliquoting is extremely common. This is defined by leaving source liquid in the source tubes, right? So you can return these back to wherever they came from, whether that be a freezer or, a different countertop. You take set numbers of aspiration and dispense cycles out of each source tube. So there's going to be a set number of destination tubes created by those source tubes. This allows you to retain that liquid in your source tubes. Sample pooling is where we're taking numerous different liquids from numerous different source tubes and putting all those liquids into one source tube. So we're creating an entirely new source liquid. Very beneficial if you're trying to create new reagents and things like that. Sample dilutions. So this is very beneficial if your lab's doing standard curves and things like that, where you need to have those accurate and precise dilutions 100% of the time. This can take small amounts of volume and increase stepwise, diluting those samples in between. Also very common that we see that. And then reagent dispensing. So reagent dispensing is essentially the exact opposite of sample aliquoting. In the reagent dispensing, what we're aiming to do here is deplete all of the source liquid and have all of the source liquid move from a source tube to however many destination tubes that amount of liquid can create. So at the end of this workflow, what you're returned with is empty source tubes and however many full destination tubes it can create out of those source liquids. The system is capable of more workflows than just this. You can do worklist-driven workflows where each dispense is different, each label looks different from the last tube. So you're not necessarily limited by these 4 workflows. This is just what we see kind of fits most lab requirements and needs. All right, we're going to keep on moving. All right, so at this point, we would like to start with a live product demonstration here. I'm going to talk through a little bit about what the machine's doing, why it's doing what it's doing. We'll talk about some of those key features as well. So if we have a little bit of patience here, we're going to get this system started, and then we'll show you. So before we get this started, what we're kind of looking at here, so this top image, this is the Scinomix AQ on the left and the Scinomix VXL on the right. We do have a bulk feeder to the right out of camera that's going to be feeding tubes into the system. Bottom left, what we're seeing, this is the aliquoting module. This is where you're going to see that pipette filling. It'll do a 750 microliter aspiration. Here in the middle is the roller position where tubes are being uncapped, labeled, and filled. This is where it's going to dispense that 750 microliters. Once it's done with that, it'll be recapped and labeled. And then on the far right side where this blue roller is, that's going to be that up-close shot of it actually dispensing the liquid into that position. And we call that position the primary exchange. All right, so right now you can see that our VXL has gripped a tube. The Scinomix AQ is now doing a liquid level detection to find the liquid level of the tube. Once it finds the liquid level, it will aspirate. It does a tip touch here to ensure that all liquid's been removed from the outside of the pipette tip. And then you can see it dispensing here into that uncapped tube. It returns over, the AQ returns over to its source liquid in case there's any droplets. That way we're making sure it winds back up into the correct source bottle. The Scinomix VXL has now labeled the tube, recapped it, and returned it back to the rack. And then the process rinses and repeats. So we're seeing again that in the back there, we have another tube ready presented for our gripper to pull into the roller. While this one's in the roller, it's being filled. There's a tip touch that happens at the primary exchange. It then later gets recapped, labeled, and then returned. So again, these tubes are coming from the bulk feeder. These were bulk loaded in from a bag, and how they're being returned to the user is labeled with a barcode and filled and capped to a set level of torque at which you specify. I'm going to remain quiet a little bit here for the rest of this so that you can see this and experience it yourself. All right, so what the aliquoter is now doing is it's going to move over to another source tube. This is because we have the sample aliquot in which it's creating 3 tubes at a time. Before it moves to another source tube, it's going to pick up a new tip, do another liquid level detect, again to reduce that contamination, and then it's going to fill. And one more thing that I want to take note of, it's a little bit difficult to see in these frames, but the gripper that's working on the Scinomix VXL side, that's our universal gripper. So that doesn't require any user intervention to change the finger sizes based on cap diameter. That's motor driven, and that is a patented Scinomix product. So that is something that you can only get from us. When the run is over, it will return everything to its home positions. It will beep to let the lab user know that the run is finished. And then this is the point at which lab users are opening those doors and removing those tubes and sending them into whatever downstream process you have. All right. I can go ahead and reshare my screen here. Bear with me one moment. All right. Keep on going. So if you have any questions about what you saw there, again, use that Q&A tool at the top toolbar of your Zoom to ask us some questions. All right, so what are some enhancing features that Scinomix offers? You saw some of the features we have here, but that's not the only products that we provide. So we have peristaltic bulk filling, which is different from what you just saw with the aliquoter. The way this works is it's going to be those good high throughput, high dispense volumes, very quick dispenses. These typically come out of one large source bottle, and they have tubing that directs it over to the roller for a dispense. This can be partnered with the Scinomix Aliquoting System. And again, super beneficial if accuracy and precision aren't of the utmost concern to you, but rather maybe throughput is. Gravimetrics I've been talking about a lot. So this is super important with liquid filling because it can do liquid validations where we know the density of your liquid and we can calculate exactly how much needs to be dispensed. And then we can confirm that using our gravimetric systems. So that's that onboard balance that we have that's capable of being retrofitted onto Scinomix VXLs. And this is accurate to 4 decimal places and down to a tenth of a milligram. Very accurate, very precise, a great asset to have in your lab. Again, exporting all of that weigh and fill validation data into that data results folder for your maybe Q&A purposes at the end or things like that that can be super helpful to have that information. Recently, we've been able to have the integration with third-party label designers. So you're no longer limited to using our software's label designer. You can use things like Bartender or CodeSoft, who's maybe creating your labels through your lab management system. We can push those print jobs into our software where each tube has an individual print job that was directed by Bartender or CodeSoft or whatever third-party label designer you have. Very beneficial, we're finding. Dual barcode scanning, super beneficial as well. So this is a new product that we have, a new feature where we can scan factory barcodes and we can also validate barcodes that we printed. So we can export the data from the factory barcode that was printed on, as well as export that data from the label that we're applying. And those can be typically data matrix we see, but our systems are capable of all sorts of different codes of barcodes. Code 128, code 39, data matrix, Aztec, QR code, etc. And then multiple tube types per run. This was released this year. This is effectively in one run, you can use numerous different destination tube sizes. So you're not limited to just one tube on your work deck at a time. You can now be handling all sorts of individual different size tubes. This is most beneficial to be used when you do have that universal gripper because, again, it doesn't have the user intervention requirements that maybe the pneumatic grippers we sell have. Again, software directed, going to be super convenient for your users to be using these multiple tubes if they have that universal gripper. All right, we're going to keep on moving. So here are those frequently asked questions that I was talking about. Hopefully this might jog your mind on a couple questions that you still have. If they're not answered by the end of this, again, feel free to put those questions into the Q&A. So, how precise and consistent are the aliquots produced by the machine? These are very accurate, very precise machines. The general benchmark we have is beneath 5% CV. 5%, if it's above that, that's when we're going to really consider that perhaps this isn't working through your workflow. Most typically with aqueous solutions, what we're seeing is that CVs beneath 2% are very common and fairly easy to do. Again, things like this depend on dispense volumes, liquids used, things like that. What is the maintenance process and how often does this machine need to be calibrated? The machine will receive one preventative maintenance a year where we're checking and confirming calibration. Again, if you have gravimetrics on board, you can check the calibration for weigh data. And if you're seeing that calibration's off, this is simply just a user selectable field in our software where increasing a value increases how much it aspirates and decreasing it decreases that. That's a static dynamic, that's a static calibration factor. And then we also have dynamic calibration factors that are being used in the background on standard curves, like I mentioned earlier, where differing dispense volumes are still staying calibrated. So it really theoretically should never be out of calibration. Can the machine handle small sample volumes while maintaining accuracy? Yes. So it's got a minimum recommended volume, dispense volume of 5 microliters. We find that the 5 microliters is easy with those tip touches to get off of the tips, whereas maybe if you're beneath that, some of it wants to stay in the pipette tip and then again, increasing those CVs. How adaptable is the machine for different experiential setups and biotechnology research? You can build your own custom workflows. So this is super beneficial in biotechnology, biology, chemistry, really anything that's using any sort of tube or plate filling. It's going to be beneficial within those fields, absolutely without question. What types of samples can the machine handle and are there limitations? There's very few limitations to it. There are a couple. Basically limitations like can the pipette tip travel over the tube? So are the tubes too tall? Things like that. But for the most part, you're building your own liquid glasses, so it can handle any liquid. It handles most labware. The most common tubes, it certainly can handle without any problem. So very, very minimal limitations. And these are all questions that we ask prior to kind of in the initial questionnaire that we have for your workflow. So we'll kind of root that out before we get too far down the line. What's the throughput for the system? So the Scinomix VXL without aliquoting, simply just with labeling, is about 375 tubes an hour. Whereas with aliquoting, it really becomes dependent on what's your fill volume, what liquid are you using, things like that can increase throughput or decrease throughput. Most typically, we see about 120 tubes an hour being filled, labeled, and capped, and then returned to those destination racks. What are the minimum and maximum dispense volumes? So the minimum recommended, like I mentioned earlier, is 5 microliters. The user is able to go beneath that, but again, that's when those CVs are going to kind of start getting a little bit higher than that 5% benchmark we talked about. And the maximum is 1 milliliter. So the single channel ADP that is capable of 1 milliliter dispenses. The users can dispense more than 1 milliliter. So for example, if they had 1.5 milliliter dispenses on the aliquoting system, it's going to take 2 trips. So the maximum it's capable of dispensing per trip is 1 milliliter. But if you have 1.5 milliliters, it's going to take 2 trips of 750 microliters, for example. What source labware can the AQ handle? So the Scinomix AQ, like I mentioned earlier, can handle all sorts of labware. You're really not limited by labware. Whatever labware you have, most typically we can use. But again, we're going to field a lot of those concerns prior to us even doing a demo with you. We'd like to demo your workflow. So oftentimes we ask that you send in your samples and we'll test them in-house before showing you how the workflow looks. How can it handle differing dispense volumes? So this is when you're driving that by a CSV worklist file, right? So where each row is essentially its own individual tube. You can customize the label data that goes on that tube. You can customize the fill volume. And if you're customizing the fill volume, that's when we're integrating that dynamic calibration factor where no matter the dispense volume, the system is still calibrated. So it absolutely can handle differing dispense volumes within one run. How does it know the liquid level? So there's two ways in which our system can opt to know the liquid level. It can do a pressurized liquid level detect, or it can do a capacitive liquid level detect. Effectively, what happens here is with the pressurized, it's going to do one liquid level detection, and then after it's done with that and the pipette's tip has been wetted, it will follow the tube's geometry, and it will know the liquid surface based on the tube geometry you inputted. Alternatively, the capacitive liquid level detection using those carbon tips is constantly in a state of knowing where the liquid level is. It can get those capacitive electrical currents through its pipette tip, letting it know that it's in liquid. So whatever works best for the user is typically what our users end up going with. And then what air handling is it capable of? So this is user selectable. Effectively, what happens here is the user can select either just discard a tube, either through a drop chute or into a discard bin. They can opt to return it to a rack and just flag it. They can opt to go over to new source tubes if there's not enough source liquid in that tube. Then maybe they opt to just move on to the next one and do it right the first time, so to speak. All right, so those are some of those frequently asked questions. Now what we're going to do is move into that Q&A session. So I'm going to have my co-panelist, Nick, read out a couple questions to me, and we're going to do our best to answer them.
Hello, everyone. Hopefully you can hear me as well. Have been kind of looking through the Q&A as Lucas has been presenting here, so appreciate all the questions, and we'll walk through and answer a few of these. Obviously, if we don't get to all of them, feel free to reach out to us, and we can set up a time with an account manager to get all your answers. First question, Lucas, from Nick Moulton is, can this pipette into a petri dish and then label the petri dish?
Yeah, so you're not limited to just tubes, right? So effectively here, what we're doing is we're going to be dispensing. This applies for 96 well plates or plates in general, as well as petri dishes. But we're working simply on the AQ side of things. So we're omitting the functionality of the VXL where that's handling tubes. You would load those petri dishes right onto the work deck of the AQ, and then it's going to be working within its own deck to fill those.
Yeah, unfortunately, we don't have the capacity to label the petri dish at this time. But as Lucas describes, we can use the AQ to aspirate and dispense. Jolene has a question. What is the smallest volume it can aliquot?
Yeah, like I was saying, most typically we suggest 5 microliters, but you can go beneath that. This is a user selectable field, so if 1 microliter, if you can get it to work, go for it. It's absolutely capable of doing it. Just again, whether or not those air rates are increasing is of concern to us.
Yep. Another question from Jolene. Is the aliquoting in a sterile environment?
So the system itself is not sterile, but we offer HEPA systems, which is a positive flow HEPA. So that's going to be blowing that 99.9% contamination reduced air throughout the system. So we have options like that, as well as some of the customers that I have are opting to put these into culture hoods and things like that where sterility is already built in. So though the system itself is not out of the box, we have a couple methods to make it.
Yeah, the nice thing with being benchtop is you can put it into one of those hoods without taking up so much space.
Absolutely.
Belinda asks, any detection mechanism for potential spills?
So on the AQ's work deck itself, no. So these are sitting in precisely engineered racks. It's going to be very hard to spill these tubes without user intervention. And it's going to be effectively, since we have deck locks and things like that, it's going to be effectively impossible for the machine to be spilling it itself. If for whatever reason the Scinomix VXL determined that it could no longer recap a tube, that would alert it that potentially a spill would be inbound, at which point it's going to do that air handling options that you select as a user. It's either going to dispose of the tube or just simply abort the run in total and wait for user involvement. Very rare you'll see spills with this, but there are drip cups and things like that that protect internal components for if, you know, the rarity happens where a spill does occur.
Yeah, accidents always happen, right? Can the system pipette from well plates to tube and vice versa?
Yes, absolutely. So again, that's when we're working on the AQ deck in particular. So we can aspirate out of those 96 well plates, and we can turn those over to a tube from a 96 well plate onto the VXL side because we consider those to be source tubes. Each individual well is considered a tube by our system. And then if you're trying to go from a tube into a 96 well plate, that's when you're working on that AQ work deck strictly.
Follow-up question to that, is there a max tube size limit, which we kind of talked about already? Would a 50 mil fit into the system's workflow?
Yeah,
The
totally.
Yes.
Yep, absolutely. Again, you're going to be limited by maybe height, very few limitations.
So Jolene asks again, what is the tube capacity for one run? And that's really dependent on your labware, right? So for a micronic style tube that's pre-racked, you have 96 in a well. We have the 12 SBS spaces on the VXL deck. So that gets you 1,152 tubes in a run for walkaway. We see a lot of 2 mil cryo tubes as well. On a 48 spread per SBS, so that gets you about 576 tubes per run. Anonymous attendee has asked how much is the perfect speed for VXL to scan and verify your barcode, and then what is the smallest barcode you can use. And again, that depends really on your tube size, right?
Yep, absolutely. Yep. So it depends on how big the label is. If you have a huge label, you can have a ton of barcode information. Things like that all are very dependent on your process.
Yep. Another one from Anonymous, can you set the system to fill and label different tube sizes in a single run?
Yep, absolutely. Yep.
Okay. A couple more here that we'll have time for, and then we'll wrap up. If your volume is greater than 1 mil, this is a good question. Do you need to have 2 lines in the CSV file?
No. So the way that it's understanding this is whatever value you input, it's simply going to divide that into equal amounts of dispenses. So if you put in 1.5, it knows to dispense 1.5 into that individual tube.
Yep. Is there only one bulk and one aliquot tube open with no cap at one time?
Yeah, so the aliquoter currently has all of its source tubes are open. Again, that's where that sterility of that HEPA filter is going to be super beneficial, as well as putting it into a hood. But all of your destination tubes remain capped. And it's using sterile pipette tips every time it goes into one of those source tubes.
Yep, that's a good lead into Belinda's question of what material are the consumable tips made of.
Yeah, so these are lab user dependent, right? So whichever ones you have, typically we can work with. They have to be automation style tips, but whether they're carbon or simple plastic doesn't matter to our system.
Yeah. Anonymous asks, what's the point of 2 different types of barcodes? And maybe they're asking more along the lines of what's the difference on the dual scanning?
Yeah, sure. So if you have a factory barcode, for example, what we can do is we can use those work lists to sort based on the factory barcode, but we can also use that secondary barcode. We can use that secondary barcode simply to validate that a label was put on, as well as we can validate and export that data itself. So it's really good for sorting and among other things. It is unique, probably in workflow, but beneficial to some.
Yeah. We'll pull in somebody new here because there's a few questions. Steve has asked, in reagent dispense mode, can the system dispense greater than 1 mil?
Per each aspiration and dispense, it's only 1 milliliter at a time, but it absolutely can do more than that. It's taking more trips at that rate.
Yep. And then we'll take one more from Sebastian. Is there multiple tips type, or the one size fit all volumes for 5 microliters to 1?
There are numerous different tip types. This is where the user's training that system that these are different tip types. So you can use whatever tip type works best for you. As long as it's an automation tip, we certainly can use it.
Yeah. Okay. If I didn't answer your question or ask your question to Lucas, we'll review these. And if we have your information, we'll send you a follow-up message as well. So
sure.
Appreciate all the questions. Very well done.
I'm going to go ahead here, and we got a couple more slides to finish up here, and then we'll be done. So if you're curious about how to contact us, best way is probably just email us at sales@scinomix.com. And if you need immediate answers, give us a phone call at 314-298-9800. You'll get right in touch with somebody who's going to help you out. And if you email us, we'll respond to you very quickly. All right. And lastly, we want to really thank you all for being here today. Honestly, this has been a great experience for us. We hope it was a great experience for you. And we look forward to seeing you and talking to you. Here at the end of January, we're going to be at SLAS. It's a trade show and convention. It's going to be in San Diego. So if you're looking to escape the cold, come see us at our booth. We would love to see you. All righty. We're going to go ahead and stop here for the day, and stay tuned for any more webinars that we have coming up. Thank you guys so much.